Only a little more than 4 light-years from Earth lies a planet that has captured the imagination of scientists around the world. Its name is Proxima Centauri b. Orbiting the closest star to our solar system, this rocky exoplanet has become one of the most intriguing places in humanity's search for life beyond Earth. Although no spacecraft has ever visited it and no telescope can photograph its surface in fine detail, Proxima b continues to inspire new questions about what may exist on worlds beyond our own. Discovered in 2016, the planet circles a small red dwarf star known as Proxima Centauri. Because it orbits within the star's habitable zone, researchers believe that, under the right conditions, temperatures could allow liquid water to exist on at least part of its surface. That single possibility changed everything. For the first time, humanity had identified a nearby rocky planet that might share some characteristics with Earth. Yet Proxima b also presents enormous challenges. Unlike our relatively calm Sun, Proxima Centauri is an active red dwarf that frequently releases powerful stellar flares. These eruptions flood nearby space with intense radiation capable of stripping away planetary atmospheres over long periods of time. Could a world orbiting such a volatile star truly remain habitable? Scientists still don't know. The answer depends on factors that remain difficult to measure from Earth, including the planet's atmosphere, magnetic field, rotation, and geological activity. This is where modern observatories become essential. The James Webb Space Telescope has transformed astronomy by observing the universe in infrared light with extraordinary sensitivity. Although Webb cannot produce detailed photographs of Proxima b's mountains, oceans, or continents, it can help astronomers study distant planetary atmospheres and improve techniques that may eventually reveal similar information about nearby worlds. Every observation collected by Webb adds another piece to an expanding picture of how planets form, evolve, and interact with their stars. As technology advances, researchers hope future telescopes will analyze Earth-sized exoplanets in even greater detail. Perhaps one day they will identify clear atmospheric signatures associated with habitability. Perhaps they will detect seasonal changes, weather systems, or unexpected chemical combinations deserving closer investigation. That possibility has inspired scientists to search for more than simple evidence of life. Some researchers now investigate the concept of technosignatures, observable evidence that could indicate advanced technology rather than biology alone. Examples include unusual atmospheric pollutants, powerful radio emissions, large-scale energy use, or other detectable effects produced by an intelligent civilization. No confirmed technosignatures have ever been discovered. But searching for them has become an increasingly important scientific field. Imagine a future observatory far more powerful than anything available today. Instead of seeing only tiny points of light, it begins separating faint signals from the planets themselves. Researchers notice unusual atmospheric chemistry that cannot immediately be explained. Independent teams verify the observations. The data appears genuine. No one claims alien civilizations. No one announces a historic discovery. Instead, scientists do what they always do. They investigate. Every ordinary explanation comes first. Instrument calibration. Natural geological activity. Volcanic gases. Unexpected atmospheric chemistry. Only after every conventional possibility is carefully tested would more extraordinary ideas even enter the discussion. That deliberate process is what makes science reliable. Sometimes the greatest discoveries begin not with certainty, but with a mystery no existing theory can fully explain. And among all the nearby worlds humanity has discovered, Proxima Centauri b remains one of the greatest mysteries of them all. As astronomers continue studying nearby exoplanets, one truth becomes increasingly clear. Every improvement in technology reveals details that were previously invisible. Today, Scientists can analyze the atmospheres of some distant planets by observing how starlight passes through them. Tiny variations in that light can reveal the presence of water vapor, carbon dioxide, methane, and other gases that help researchers understand the nature of these distant worlds. Future observatories may push these capabilities much further. Larger space telescopes equipped with advanced imaging systems could one day isolate the faint light reflected from rocky planets like Proxima Centauri b. Instead of relying only on indirect measurements, astronomers may eventually study weather patterns, cloud movement, surface composition, and long-term climate changes with far greater precision than is possible today. Imagine that during one of these future observations, researchers notice an atmospheric feature unlike anything predicted by existing models. Not proof of alien technology. Not evidence of an advanced civilization. Simply an observation that refuses to fit current scientific explanations. The first response would not be celebration. It would be skepticism. Independent observatories around the world would attempt to repeat the measurements. Instrument specialists would search for calibration errors. Planetary scientists would test volcanic activity, chemical reactions, and every known natural process capable of producing the same signal. Only after years of careful analysis would researchers begin asking whether an entirely new scientific explanation was needed. History has shown that many important discoveries begin this way. Unexpected observations have repeatedly forced scientists to revise their understanding of the universe, from the expansion of space to the existence of planets orbiting other stars. The search for life beyond Earth follows the same principle. Evidence must come before conclusions. Meanwhile, artificial intelligence is becoming an increasingly valuable partner in astronomy. Modern AI systems already help identify galaxies, classify stars, detect exoplanets, and organize enormous amounts of observational data far faster than human researchers could manage alone. Future generations of AI may discover subtle relationships hidden within decades of telescope observations. Even then, the AI would not replace scientists. Its role would be to highlight unusual patterns worthy of investigation. Human researchers would still determine whether those patterns represent new physics, rare natural events, or simply statistical coincidence. That balance between advanced technology and careful scientific verification is what drives astronomy forward. The James Webb Space Telescope has already transformed our understanding of the cosmos. It has revealed some of the earliest galaxies ever observed, explored the chemistry of distant planetary atmospheres, and provided extraordinary insights into how stars and planets evolve. Each discovery reminds us that the universe is more diverse and more complex than previous generations imagined. Proxima Centauri b remains one of the most fascinating nearby worlds because it represents possibility. A possibility that future telescopes may someday investigate in remarkable detail. Whether that future reveals a lifeless rocky landscape, a planet with unusual atmospheric chemistry, or evidence of conditions favorable for life, every answer will deepen humanity's understanding of its place in the universe. Perhaps the greatest lesson is not that we expect extraordinary discoveries. It is that we continue searching with patience, curiosity, and evidence. Somewhere among the hundreds of billions of stars in our galaxy, countless planets continue their silent journeys through space. Many will remain mysteries for generations. Others may surprise us in ways we cannot yet imagine. Until that day arrives, every new observation brings us one step closer to answering one of humanity's oldest questions. Are we alone? For now, the universe remains silent. But with every new telescope, every new mission, and every new discovery, we become better listeners.